In this video, we briefly discuss a series combination of capacitors. So we want to find an equivalent capacitance for three capacitors connected in series here. So what we want is for the same current voltage relationship to exist in both circuits. So in the left circuit, we have the same current flowing through each capacitor, so we can write the following. So the time derivative of the voltage across each capacitor times that capacitance is the current, and then the current is the same through each capacitor because they're connected in series. Kirchhoff's voltage law still holds, so we have this. In the equivalent circuit, we want the same current and voltage relationship, so we write this. Then we can put in this equation into there, so we have this. Next, we're going to use this equation, and we can write the derivatives like this. Right, so I just divided these two both by C1, and we can do the following. Now we take these and plug them in here. And then I factor out the IS. Now notice we have IS on both sides of the equation. What that means is that this has to be 1. And what that means is as follows. And we can generalize this for n capacitors connected in series. We have this equation, and we just note that capacitors connected in series combine like resistors connected in parallel.